Good morning, ladies and gentlemen. Welcome to week 21 of your SAT Math Prep. This video will back up our live instruction for the sophomores. For those students that either are absent the week of March 14th from their plug time day for math prep, or for students who need a refresher before they finish or make up the assignment for the week of March 14th. That assignment is found on Quiz-Is, and the link to the game can be found on Google Classroom. All right, so we are talking about factoring and equivalent expressions for the second week in a row. So we should be able to go through these four examples relatively quickly. Example 1 says, when the given expression below is rewritten in the form x plus a times x plus b, where a and b are constants and a is greater than b, what is the value of a minus b? So the expression that we are given is a trinomial, which means we are supposed to be factoring that trinomial, which means we're looking for a pair of numbers that multiplies to c and adds to b, or multiplies to 15 and adds to negative 8. In order to multiply to a positive number, the signs would have to be the same, and in order to add to negative 8, they would both have to be negative numbers. The numbers that multiply to positive 15 and add to negative 8 are negative 3 and negative 5, which means that this trinomial factors into x minus 3 and x minus 5. So my two numbers then, the a and the b, are the negative 3 and the negative 5. So we have to say to ourselves, okay, well, the bigger of those two numbers, negative 3 is greater than negative 5. So since a is greater than b, that tells me that a is negative 3 and b is negative 5. As such, I can take those values, negative 3 and negative 5, and I can plug them in to find the value of a minus b. That would be negative 3 minus negative 5, which would really be negative 3 plus 5, or 2. Example 2 is similar to one that we did on last week's video as well. Those equivalent expressions, ax squared plus abx, is equivalent to 3x times the quantity 2x plus 10 for some constants a and b. And then it asks, what is the value of b? So we have to realize that we need to take this expression here and we need to make it look like this, which means we need to get rid of the parentheses. We need to distribute 3x through to both terms. So that would take this expression and rewrite it as 6x squared plus 30x. When we compare that to ax squared plus abx, we should immediately realize that a is 6. Okay, this tells us that a is 6. The other thing we should notice is that a times b equals 30. Well, if a is 6, then that's 6 times b equals 30. And then we would divide each side by 6 to give ourselves an answer that b has to be 5. These are both relatively common styles of question on the SAT. They ask us to take an expression and either factor it or distribute or add and subtract like terms to get a different form of the same expression. Then they ask us to figure out, through the use of variables, through abstract constants like a and b, what numbers should actually be there. So we need to be relatively comfortable with the underlying processes, adding and subtracting like terms, factoring, multiplying, distributing, stuff like that. All right, on to examples 3 and 4. So on example 3, we have another problem similar to example 1, except now instead of a equaling 1 and being simple factoring, a is not equal to 1, and we have to do what you have heard in class described as Michigan M factoring. So we're supposed to take a times c, which would be 21, and find the two numbers that multiply to 21 and add to 10. So we need the two numbers that multiply to 21 and add to 10. Well, that would be 3 and 7. Then we take that middle term and we break it up into a 3x and a 7x. This 10 right here gets broken up into 3x and 7x. So we take this and we break it up into these two numbers. Then we group the first two terms and the second two terms and factor the greatest common factor out of each set of parentheses. So the first set of parentheses has a greatest common factor of 3x. When we factor that out, we're left with x plus 1. The second set of parentheses has a greatest common factor of 7, and when we factor that out, we're left with x plus 1, which means my two factors are x plus 1, which is what's inside the parentheses, and 3x plus 7, what is in front of the parentheses. Now we compare that to the expressions in the problem, ax plus b and x plus c. And what that tells us is a has to be 3, b has to be 7, and c has to be 1. Then we are going to take those values and we are going to answer the question, what is the value of a minus b plus c? So a minus b plus c would be 3 minus 7 plus 1, which would be negative 4 plus 1, which would be negative 3. Okay, the final question is more of an application question. It says the area of a rectangular garden, so we'll draw ourselves a rectangle. The area of a rectangular garden can be expressed as a trinomial x squared minus 5x plus 6. Which of the following expressions could represent the perimeter of the garden? Well, we need to remember that area of a rectangle is length times width. So if we take this area expression and we factor it, two numbers that multiply to 6 and add to negative 5 are negative 2 and negative 3. Simple factoring like we did in example 1. Those two expressions could very easily represent the length and the width of this garden. In which case we are able to find the perimeter because that means we know the lengths in terms of x of all four sides of the garden. So the perimeter would simply be the sum of those four sides. So x minus 2 plus x minus 3 plus x minus 2 plus x minus 3. Or you could write it as 2 times x minus 2 plus 2 times x minus 3. Either way, when you expand that out and combine like terms, we are looking at 4x minus 10 as a possible perimeter for that garden. Okay, so that does it for our week. Once again, there is an assignment that you are expected to complete through Quiz. There is a link to that assignment on the Google Classroom, and your Google Classroom code for regular sophomores is shown on the screen, Q7ULRP5. So hopefully you're already a member of the Sophomore SAT Math Prep Plug Time classroom, but if not, please join that classroom and complete the skill check for the week of March 14th. That is the skill check 3-14. Thank you very much for your time and attention.